Hi, and welcome to our mini class, COI versus reality. What is the coefficient of inbreeding and why is it no longer our best tool? So what is the coefficient of inbreeding? It's a statistical calculation designed to give us a probability that an animal will inherit the exact same gene from the exact same ancestor. So there's a lot of incorrect assumptions about what the coefficient of inbreeding is. People often believe it means what percentage of your dog is influenced by an ancestor, or it means your dog is as inbred as its COI, meaning if it has a 12.5% COI, it means it's 12.5% inbred, or 12.5% of its genes are identical pairs. So here's a visual of what the coefficient of inbreeding assumes. So it's a correct assumption that 50% of your genes come from your sire and dam. But here is the assumption of coefficient of inbreeding down here. It assumes that 25% of the genetic material of these puppies down here is directly attributed to this grandsire and granddam. So it assumes that 25% of the genetic material is inherited from each of the sire and dam's parents. Statistically, in simple genetics, this is true. If you were going to statistically predict, that would be what our prediction would be. However, why would this be wrong or incorrect? When our bodies or any animal creates gametes or sperm or eggs, something called recombination occurs while the cells to create offspring are made. This is a reshuffling of the genetic material received from the sire and dam of a dog, and therefore the genes from their sires and dams. This recombination is called crossing over, and the chromosomes literally switch genes. This can happen all along the length of the chromosome in small or large chunks. So here you can see here's our two drawn chromosomes. And over here, this is what happens. It's like they trade arms. Now, this can happen in very, very small segments or very, very large. This is showing large in this example. Now, what would be a genetic advantage of this reshuffling? Recombination, or this new combination of genes, may make an animal better suited to adapt to its environment and have better vigor and potential to survive. So it's giving animals a new combination of genes in case there is a challenge to that animal that its parents maybe wouldn't have been able to survive. It will be able to. Okay, so what would recombination look like if we were going to make it into a visual? So here again, an individual receives 50% of its genes from its sire and dam. However, down here, we can't make the assumption that 25% will come from that original grandsire and granddam. So in this puppy, there's more influence from that maternal grandsire than there is from that maternal granddam. And in this puppy down over here, there's more influence from that paternal granddam than the paternal grandsire. Notice how the amount of genetic material from the original two granddam and grandsire up here is vastly different in each puppy than in our previous visual. Coefficient of inbreeding continued. This really was the best that we had when it was all that we had. When pedigrees are accurate, this does give a good perspective to consider. Knowing your pedigree is always going to be important. We are not advocating for looking at things without your pedigree. Just as knowing the health, temperament, structure, and drive of your lines is important, and sticking to your individual goals as a breeder. Okay, so let's compare the two images again as we sum up here. In the coefficient of inbreeding expectation, 25% of the genes of a puppy will come from one of the granddams, and then the other 25% comes from the grandsire. And then over here, you can imagine that these yellow and red would also have 25%. Same on this side. In reality, there is recombination, and each puppy receives a different percentage of each grandparent and grandsire. So as you look at these visuals and note the differences in the contribution of the original granddam and grandsire, consider this happening for many, many generations' time, and you can appreciate how vastly different the genetics would replicate as opposed to what the statistics would tell us. Okay, well, that is it for this little mini class. If you have any questions, you can email us at theteam@betterbread.com. Thanks for watching.